Welcome to our Checkpoint 2 presentation, which is the multiple linear regression of the case study. So our first research question, we wanted to analyze, do poverty rates, education, employment, and police budget affect total crimes per population? Our null hypothesis is that the betas of percent pop under POV, percent not high school grad, percent unemployed, and police budget per POV are all equal and equals 0. Our alternative hypothesis is that at least one of these beta predictors is significant for predicting the total number of crimes. So in this test, we found that the intercept, which is the total crimes per population when all the other betas are 0, is 4,837 crimes. And that was a significant value. Going forward, we saw that the percent pop under POV showed a value of 350, which is also significant, indicating that a unit increase or percent increase in percent population under poverty increased the total crimes per population by 350. Along with that, the percent unemployed showed a negative value of negative 135, and this was not significant, but it does demonstrate that a percent increase in percent unemployed decreased the total crimes per population by negative 135. Then the police budget per population is highlighted to show a difference in the next research question, is an increase in 0.001, which is very small impact, and it's not significant. Finally, the percent not high school grad is negative 47, which is significant, indicating that a percent increase in not high school graduate decreases the total crimes per population by 47. Along with that, our coefficient of determination, or R squared, is 0.4295, indicating that the variability in the total crimes per population can be explained by that much for these variables.
For our VIF, in this, you can see all these values for percent population under poverty is about 2.7, percent not high school grad is 2.6, percent unemployed is about 3.8, and police budget per pop is about 1. All of those are well under 5, which would support not a strong collinearity between the betas. However, you can see two sign changes here in the coefficients, and that led us to believe that there is some collinearity. So running pairwise tests, you can see strong correlation between poverty and percent not high school grad, between poverty and unemployment, and between unemployment and percent not high school grad, with those being 0.66, 0.79, and 0.77 respectively for their R values, and all variables demonstrated significance through a correlation test. So through our residuals versus fitted plot, you can see there's pretty much consistent variance throughout. There are some possible outliers towards the ends. And then in our QQ plot here, you can see it roughly follows the line. There are some possible outliers again on the edges here, and it's drifting away from the lines towards the end, which may be evidence of heavy tails.
Our second research question aimed to improve the impact for the police predictor. So this time we replace the budget with number of police on patrol, and our null hypothesis states that all the betas, so percent of the population under the poverty line, percentage not high school graduates, percentage unemployed, and the percentage of police on patrol all equals 0, and our alternative hypothesis is that at least one of these beta predictors is significantly predicts total crimes. As you can see, the coefficients for this model are mostly similar to the original model, with the intercept coefficient being 4,229. This is highly significant. So with all other predictors being 0, we can say that the number of total crimes should be around 4,000. And the percentage population under poverty is 354, which means that with a unit increase of the percentage under the poverty line, we will see a rise in 354 total crimes. This is also a very significant figure. We have the percentage unemployed, which is a negative predictor, so we have that circled as well, and that is 158, so same with the unit increase. And then with the police on patrol, we actually see a positive impact versus basically no impact in the original predictor. So this shows that there is at least some impact on police on patrol versus crimes, but it actually increases crimes by 9 crimes per percentage increase in police on patrol. This is also not very significant. And then we have our percentage of non-high school graduates, which shows a decrease in crime for every unit increase in percentage. This one is significant, but only to a 0.5 or 0.05 significance level. So take it with a grain of salt. And our coefficient of determination is 0.4253. So about 42% of the variance can be explained by the model itself.
For this, for our second model, the VIF, values are very similar, with percent population under poverty being 2.1 and 2.7, percent unemployed being about 3.7. The police, the percent police on patrol is very similar to the budget at about 1 for its VIF value, and then percent not high school grad around 2.5. We don't have any really significant difference with pairwise correlation between the two models, because the policing metrics didn't really correlate with any of the parameters that we used. And then seeing our assumption shorts, constant variance, and QQ plot, very similar to the ones that we have for the first model, with some outliers as we get farther to the edges. And that is our checkpoint 2.
Thank you.
Thank you.